Okay, all right, so let's go ahead and get started. Welcome to Building Resilient Applications Through Chaos Engineering and Observability between Epsagon and Gremlin. We'll do a round of introductions and we'll tell you what the agenda is going to be for today. So hey folks, my name is Austin Gunter. I'm the Director of Marketing, Product Marketing at Gremlin, the enterprise chaos engineering platform, and I am joined today by my buddy Chris from Epsagon.
Hi everyone. Thanks for taking the time to join us today. My name is Chris Harding. I am a member of the sales engineering team here at Epsagon, where we provide a modern applied observability platform. Looking forward to this.
Awesome. So we have a really fun agenda for you today. We're going to be using Gremlin and Epsagon to do some real-life chaos testing inside of a microservices environment that Chris has spun up. So we're going to be injecting real failure into an actual environment and observing how that failure impacts the system as a whole, the UI, etc., and use Epsagon to identify where the failure points are happening in order to do things like decrease mean time to detect, mean time to resolve. We'll be showing you how to use proper chaos engineering tests to test and validate monitoring and alerting systems inside of Epsagon, and we'll go in depth and explore debugging use cases. So before we get started with the actual fun breaking stuff, we'll set the table a little bit with some context. So if you're on this webinar, it's probably because you're in a company that's cloud native or approaching cloud native, adopting things like Kubernetes or microservices, moving to the cloud, or adopting DevOps. So all these things are amazing. They help us as engineering teams move faster, get features to customers more quickly, or realize business objectives. But this velocity comes at a price because these modern applications become exponentially more complex with all these great innovations that were happening. And with this complexity comes real business impacts where, e-commerce companies will have Black Friday failures that impact customers in store or online. We've seen bank failures that prevent customers from managing or accessing their money or trading. And then even airline incidents where the booking and registration systems will strand or delay passengers, and sometimes, airline failures can actually put people's health and safety at risk. And most of these issues are found by customers before the operations teams can actually identify them, which is a huge problem. Actually getting to the bottom of what caused, what the causes are, because it's never really just one, but what the causes of failures are in distributed systems is painful and time consuming. And every minute lost is very expensive for the business. So how do we get ahead of these problems? That's what we're going to be talking about today. The challenge is that traditional approaches and tools to identifying failures are not enough. So let's start by talking about monitoring and observability.
Yeah, absolutely. Great point, Austin. And so by way of context, prior to joining Epsagon, I'd spent a number of years as a full-time engineer, most recently at a large Fortune 100 company, moving their application into the cloud and embracing microservices. And so I'm all too familiar with this pain. And that is that the traditional tools one uses are very much not well built for those types of environments. And so what we see is you might have a tool for your logging, you might have a tool to understand what's going on in your Kubernetes resource consumption. And so you have to go toggling and context switching back and forth to get that complete picture. And so that's something we want to solve here at Epsagon. Even further than that, there's a large difficulty in correlating data from multiple services, trying to understand for a given request which log is associated. And so those are some of the challenges that we've seen here at Epsagon and I've seen previously as an engineer. All right. Highlighting what I mentioned, specifically troubleshooting with logs in a microservice environment does not work very well. I've had this horror myself trying to troubleshoot live production issues, and you're going through logs for service A, trying to figure out how they relate to the logs from service B, and it can be near impossible at a production level scale. So how do we solve that? How do we get better observability into our microservices. Here at Epsagon, we look to combine what we call the 3 pillars of observability, that being tracing, metrics, and logging in a really intelligent way, and correlating it such that from a single pane of glass, you're able to not only see your metrics, but then see which traces ultimately contributed to those metrics, and understand what log information came for a given request.
Let's see. Yep.
And so the way we handle it, Epsagon is very much a distributed tracing-centric observability platform. And for those of you who are not familiar, what a trace is essentially the ability to tell the story of a transaction or workflow as it propagates through your system. And we can see that here with some of these images, being able to understand the path that a request took and its status at each step. This distributed tracing historically has been something available only to sort of the very tech large organizations, founded at a place like Uber. But with a tool like Epsagon, we can bring that same level of visibility to your organization.
That's great. Just as a note, we both turned our videos off. We were lagging a little bit, but we are still here. So the monitoring, troubleshooting with logs, observability, and tracing, those are amazing because they allow us to debug a system like as a problem's happening or after a problem has happened. But it's even better if we can get ahead of problems before our customers find them, before they cause an incident. Now, traditional testing methodologies don't really give us a way to proactively find these failures before they impact our customers. We've got unit tests that will test, an element of code to make sure that it does what we say it was going to do, and an integration test that makes sure that one piece of code plays nicely with another piece of code. But that's really just looking at the top of the application stack and doesn't look at changes in upstream dependencies from our services or configuration drift or any sort of change in our infrastructure, much less how people and processes respond to incidents. So we want a more proactive approach in order to identify these failures in advance. At Gremlin, we believe that chaos engineering, the thoughtful, controlled experiments that are designed to reveal weaknesses in our systems, are the best way to test our people and processes, to test failure at the application and request level, and test things at the infrastructure and network level. Now, let's pause for a moment and clarify what we mean by chaos engineering, because there's a lot of confusion, I think, coming out of the V.1 of chaos engineering from Netflix with Chaos Monkey, which most people are familiar with, which is that, we're sort of like randomly injecting failure into our systems, or some sort of haphazard, chaotic way of identifying failure. That's not what chaos engineering should be. Chaos engineering should be the scientific method of starting with a hypothesis, saying, what happens to my system if this little component fails, or if there's a little bit of latency, and then expanding the blast radius progressively and incrementally from there to test the system and isolate the problems, and then mitigate risk while we're doing this. And we'll show you we'll show you what this looks like in a moment. So when you bring chaos engineering and applied observability together, because you're proactively looking for failures and then able to trace the system and isolate them with an observability tool like Epsagon, you can reduce the incidents that your team has to firefight. You shorten your mean time to resolution, and of course your mean time to detect before that. You'll ship code faster, and you'll launch much, much more successfully because you've identified bugs before production found them for you effectively.
That's great. And so from the Epsagon side, from an observability point of view, what we really want to provide you is that full end-to-end picture of your application stack as transactions progress through each of those services. That requires, as I mentioned earlier, the ability to correlate things like metrics, logs, and traces, while also providing full payload visibility, and we'll see that in a little bit shortly. The Epsagon solution is built to run anywhere, whether that's Kubernetes, which is what we'll be focused on today, ECS, containers, serverless, and it is extraordinarily easy to set up. And I am sure that everyone says that, but we really mean it here at Epsagon. And so to instrument the service, you can largely do it without a single line of code change in just a couple of minutes. And that really separates us from some of the competition. And of course, for any SaaS solution, we have to keep security top of mind. And so you can see some of the certificates we have here, whether that's GDPR, SOC 2, we're one of the only APM tools that are HIPAA compliant. And so we always have a core focus on security.
Yep. And on the Gremlin side of things, of course, security is really important. We're SOC 2 certified with robust RBAC controls, MFA, and SSO. Gremlin's tool is also very simple to use, and you'll see the UI in a moment. We also have a well-documented API. There's a lot of safety measures built in because if you're going to be testing for failure, you need a way to safely halt and roll back and experiment, and we'll show you how that works in a second. And then, of course, comprehensive. Distributed systems can fail in many different ways, and Gremlin is the most comprehensive tool with attacks across every layer of the stack, from the application level down to the state, your resources, and the network. Okay, cool. Let's get to the fun stuff, right? We're going to do a demo, and this is a view of the reference architecture that Chris has built up. This is where we're going to be injecting failure. Chris, you want to explain this a little bit?
Yeah, absolutely. So what we've built is a very basic and very visually unappealing mock e-commerce site with just some basic services built in. So we have our front end in React. We've built a traffic service that has a little bit of logic around routing, and then the services you would need for things like a product catalog. We serve some ads, a cart service, as well as a charge service. And so we'll see all these as we get into the application.
Cool. Now I'm going to switch my screen and pull up the Gremlin dashboard. All right, so let's do a walkthrough of what the Gremlin tool actually looks like. This is the home screen dashboard. And one of the first things that you'll be greeted with when you log in is we collected a little bit of information about your architecture so that we understand what tools you're using to orchestrate your containers, what you're using at your compute layer, monitoring your message queue or message bus, and your databases. And then we'll recommend specific chaos experiments. We call them scenarios that you can run right off the bat that are based on common real-world failure modes that those technologies face on a regular basis. So you can right away start inoculating yourself against common failures. And we'll show you how those scenarios work in a minute. You can also see on the dashboard that we've got, here's all the targets where the Gremlin agent is installed. So this is literally the infrastructure that we have available to us. You can see the total number of attacks that have been run recently over different time periods, and get a sense of your reliability efforts. This gives you a good sense of visibility into, so your leadership can see what your reliability efforts are, and you can correlate that to a reduction in incidents from all of your efforts. Now, from a permission set perspective, we are inside of the Epsagon company, and then we are inside of the solution engineering team. And what the teams are inside of a company is permission sets. And we want to ensure that only teams that are responsible for writing code, for deploying code, for handling incidents can perform chaos experiments. So we don't want anybody who's not responsible for that code base to be able to inject failure into our systems. And this is how we keep ourselves safe. All right, there is great documentation inside of Gremlin that you can always check out by clicking on the API side. That's lagging a little bit, but you can see all the documentation. So that's available right inside the UI. And then the fun stuff, you can go over to create new attacks inside of Gremlin. This is where the failure actually happens. So I'll click new attack, and I can select to attack hosts, and you can see each one of the hosts where Gremlin's agent is installed. This is the environment that we have. We can also attack specific containers. We can look at the application or request level. And then because we're running in a Kubernetes environment, you can see the UI changes here. We can attack individual Kubernetes resources. So we can very, very get granular about what we're attacking. Let's say I wanted to target everything. I can go down here and select target all, and you see that I get highlighted in the UI. And then I go and select a Gremlin. And like we said earlier, we can start at the resource level. We can consume CPU resources and see what happens if there's a spike in that. We can consume disk space, system device resources, so I/O, or consume memory. At the state level, we can kill specific processes and see how the system responds. We can shut down a host. This is like the artist formerly known as Chaos Monkey. Our tool with shutdown is a lot more granular rather than sporadically or randomly shutting down hosts. You can schedule this or control that so you learn more about your system. And then we can do time travel. This is a great way to change the system time and see if your certs expire or if you're prepared for daylight savings time, for example. And then some of the more popular attacks are the network level. I can black hole traffic between service A or service B. I can monkey with DNS access. I can add latency between requests on the network because the network is never stable. And I can also induce packet loss. And then, of course, we can combine these together into scenarios where we daisy chain increasing amounts of failure into our system. And we'll show you how this works in a second. But I'll hand it over to Chris now, and you can pull your screen up, Chris, and start walking through the Epsagon tool before we start breaking stuff.
All right, great. Are you able to see my screen?
It's loading. Still loading. Here, unshare that and try and share it again and see if that takes care of it.
All right, sorry about this all. Technical difficulties here with the big marker tool. Let's try again. I think that looks a little bit better.
Yep.
All right, great. So, I'm sure as everyone can appreciate it, it's going to be hard to do justice to the tool in just a few minutes here, but let's just give you a high-level understanding and some context, and we'll dig in a little bit deeper as we get further into our demonstration and we actually start breaking things. I'll start here by looking at what we call our service map. I'm sure you can tell just by seeing this that it's providing you with a high-level architectural overview of your application, its constituent services. In this case, this is very much a Lambda serverless-based application, but we'll see it works for any containerized workload. And so it's showing those services as well as any of the middleware pieces that we can see. And so one of the things that really separates Epsagon as a distributed tracing platform, as an observability tool, is again our ability to give you that true end-to-end picture and to be able to trace through things like Dynamo Database or like S3 or like Kafka, if that's something you use. And so we can ensure that you're always getting that full and complete picture. All right, you can also see we have any third-party external APIs that your application is speaking with. This service map is a great place to understand the health of your application at a high level, whether that's trying to understand things like the latency between any two given services, both synchronously and asynchronously, or even trying to understand things like an error rate for a given service. And so we can see this specific Lambda has over a 40% error rate. I can also see, if I use focus view, what the downstream impact might be. We can see in this case, auth0 is downstream, and so most likely our users are not able to authenticate. And that's something we're clearly going to want to understand and resolve ASAP. Let me click into this service. We'll just see some high-level metrics. We can see the successes and errors, the average duration, as well as that duration broken out by constituent part. And so we can see a majority of the time here is being spent on that GET request out to auth0. Important point I want to mention here is that at Epsagon, we do not sample data. And so when we see here on September the 6th, we had 2,140 successes, 852 errors. We can be confident that that is a true, accurate, and complete representation of all of the traffic that has come through this service. You will not lose traces due to sampling, as you would with a large number of the other tools out in the marketplace. All right, so we started at a very macro level. We know we have a service that has a high error rate. Let's dig into the actual traces from this service to understand what's going on. You'll see it's brought us into our trace search view. It's appended some filters so that we're only looking at this specific service. We have some high-level visual metrics here, but then as we scroll down, we can see the individual traces that are being sent. I will point out we have used the Epsagon API to enhance our traces with additional information. You can see request type and user ID, and that becomes really valuable because I can now actually add another filter and say, just show me the traces for a specific user in this service, and that's what we see here. I'm going to come in and click on one of our successful traces. You'll see it brings up a view that looks very familiar to us. It looks very similar to the service map. The key distinction here is that it's only showing the services that took part in this single business transaction. And it's giving you that end-to-end view and understanding of what happened at each step of the process. Really important is that we give you full payload visibility here at Epsagon, and so we can see that information here. It's tremendously valuable not only for troubleshooting purposes, but we can also leverage it in some interesting ways, as we'll see shortly here. All right, in addition to that graphical view, we have the timeline view, which just gives it broken down again by constituent part, and again with that full payload information. I'm going to minimize this successful trace. Let's open an error and see what we can visualize there. And so we have the ability now to toggle back and forth. We can understand the delta between, let's say, a success and an error. But very important, as I mentioned earlier, is that context, is that correlation, is that ability to understand for this trace. We have context to not only the stack trace information, but also the logs that are only specific to this request. And so there's no need to dig through your logs and try to understand, which log lines correlate to this request. All of that is done automatically out of the box. And so we've been able to very quickly start at a high level, identify a service with issues, dig into the traces and the logs, and now we know what that root cause is. In this case, an expired JWT. And I've been very quickly able to understand the issue and ultimately know now what I need to do to go and solve that. All right, very quickly here, there are, of course, other ways that you can filter your traces. I mentioned that we have the ability here at Epsagon to trace through those middleware type pieces. And so we can actually say, show me all of the traces for Dynamo database, and only further than that for the update item operations. And so if you're using Postgres, you would see those operations. But now we've been able to filter down all of the DynamoDB updates across our entire application. And again, we can see that trace and this full payload information. And one of the things that's really valuable here is how we can leverage this. And so we had a customer not long ago who told us that their biggest pain point was being able to say, I want to see all of the traces associated with a specific user token or a username. We can do that in a couple of clicks here at Epsagon. We can create what we call a custom index tag. We can select the payload field that we'd like to index. We can give it an alias. I won't do it here. We are in a demo environment. But what this does is it now makes username a field that we can filter on from within our trace search. So really powerful having that payload, being able to leverage it to create these custom filters on the fly with no code changes required. And so that's something that's really powerful here. All right, we've looked at sort of a high-level service map. We've dug into the traces. But there will be times when the issue in your application might be more related to something like resource contention. And so, of course, we want to provide a window into that. Here are, for example, our ability to look at Kubernetes. We're looking at, of course, we can see information at the cluster level. We can look into our nodes, into our pods, into our containers, and again, have that full context to allow us to say, okay, I see this pod. Show me all of the traces associated with just that pod. Or we'll have the context to say, we have our containers here. Show me the container logs. And those will be available to you as well, as we see being pulled up here. It's going to be very similar for ECS, so I won't belabor the point. I'll come in just to serverless very quickly to show that, of course, we're able to trace through serverless functions as well. And we can actually do this by auto-instrumenting right from our UI. If we wanted to trace these two functions, we can select this, click Enable Auto Tracing, and then they're automatically going to be set up without, again, you having to do any code changes. As we click into a given function that's being traced, we can see, of course, metrics around that function, and then again, that idea of context to both our CloudWatch logs just for this invocation and our ability to see that trace where the invocation took place. Lastly, we have, of course, we're not just focused on mean time to resolution, but we want to be able to proactively alert our customers when there are issues. And so we have a very robust alerting infrastructure here that I won't go into in too much depth here because we'll actually use it as part of our demonstration. But the ability to create alerts based off of Lambda events, Lambda metric, let's say we want to alert if there are a certain number of errors, Kubernetes metrics like CPU usage, and then the ability to create trace-based alerts off of any of those filters that we saw earlier, including those custom payload filters that we've used. All right, I think that in the allotted time here, it should give at least a good high-level understanding of the Epsagon platform. Now, Austin, what do you say we start breaking things?
Yeah, man, let's break some stuff.
All right, great. So I'm going to pull up the Gremlin tool here, and we're going to start with a relatively straightforward attack. And what we're going to do as we click on New Attack here, let's target all of our hosts, all of our nodes within our K8s cluster. And let's do a resource attack on something like the memory. So I'm going to choose 1.3 gigabytes here for each node. I'll show you why I chose that number as we kick off the attack here.
Why don't you show them the store as well?
Yes, great point. So here is our actual e-commerce store that we've built. We'll see as this attack starts kicking off. Let's use this store to try to understand what that impact is. And so we'll let this kick off. We can see it has a little bit of priming time where it's getting ready to kick off. It allows you to, let's say, halt an attack that maybe you didn't actually want to run, but now we're underway here. And so if I come back to my store and I start refreshing it, we can see the impact is essentially negligible. And that's not too surprising, right? I mean, this is a very lightweight e-commerce store that we built here. And so we can see it doesn't have a large impact. And let's see that also being represented from here within the Epsagon tool. So here I am within my Kubernetes clusters. As we go here and I click on nodes, we can see here, just as we expect, that this memory is spiking at each of our nodes. It's 1.3 gigabytes plus whatever sort of the native workload is. And the reason I chose this number is because I wanted to get somewhere around 70% of our overall limit for our cluster. And so if you do 1.3 gigabytes times 5 plus the native workload, you're at about 7 gigabytes. But as we saw, that hasn't impacted our store. Of course, if it gets to a higher threshold, there is a threshold where it will break. And so you might want to set up alerts to let you know, for example, if you're getting near that 70% threshold. And that's something we could do within the Epsagon tool. And we'll look at alerts again in a little bit here. All right, so our attack's done. We haven't actually managed to break anything. Let's see if we can maybe do a little bit better job in our next one. All right, so the next attack that we're going to run will be a latency attack, and we're going to do it instead of at the host level. Let's move over here to our container level. I'm going to select a specific part of our application, which is our product service. We can see here it's showing us what's ultimately going to be selected and targeted. And then let's choose this gremlin here. So let's do a little bit of latency. And let's do it, let's say something like 1500 milliseconds. Let's choose a really high threshold to start. Hopefully we can do some damage here.
What do you think is going to happen with a second and a half of latency, Chris?
I think we're going to break something, and I might have some inside knowledge as the one who built the store. But let's see if that actually comes to fruition here.
Yep.
All right, and so we can see, indeed, it looks like we have broken that product catalog. It's not showing up anymore, and that's not too surprising. What we've learned here is that at 1,000 milliseconds, our product service fails. We've also learned that we should probably have a better way of handling this from a UI perspective, right? If a user comes and the product service has failed, you probably want to give them an error message, at least so they know what's happening, because right now this looks pretty bad here. All right, so what I want to do, now we know we broke this service, how would you troubleshoot this? You have a customer or someone else within your organization who has said to you as an engineer, the site's broken. That's all you've gotten. Unfortunately, that's pretty common. And so what can we do? Let's come in and look at our traces, and let's filter down and only look for all of the traces where we produced an error. Right, and so we can see those here. We can see our product request path. Let's click in through here. And again, now we're able to very quickly understand what happened, right? We had a timeout exceeded. That tells us that from the stack trace. If I come in further and look at my node execution, I can, of course, view the logs, and we'll see those open up. And it's going to show me all of that output, all of that debug output. for this node service. And so if I scroll down, we can see here that we have a timeout of 700 milliseconds exceeded. That makes sense. We sent 1,000 milliseconds. And so that ultimately is why our store is failing here. All right, so very quick being able to troubleshoot once you have an issue is a real core value of the platform here. I want to see something. We can see I've cheated a little bit here. In advance, I did set up an alert to tell me essentially if we have that product service error, if we have more than one error over a 5-minute time frame. And what's really nice is once being alerted, I can click through. It's going to show me only the traces that ultimately triggered that alert. And so you're alerted to something, you can very quickly identify and see the actual traces that triggered that alert. All right, interesting. So Austin, we know, because I looked into our logs, that 700 milliseconds is sort of that timeout threshold. But let's say we didn't have that or we didn't know that. How can we leverage the Gremlin tool to try to understand what that breakpoint is, but maybe even further, at what threshold our website becomes maybe less friendly for our users and it's not performing as we'd like?
Yeah, so Gremlin makes it really easy to build like incremental tests with what we call scenarios, like I said earlier, which is effectively a daisy chain series of attacks where we can incrementally increase latency to a particular part of the system in order to observe the system behavior. To your point earlier, we want to know where the system breaks, but we also want to know where it starts to fail and where customers start noticing this so that we can identify opportunities to bake in redundancy, set up the proper alerting, and also make sure that there's this concept of failing gracefully, right? Just customers may notice problems before there's an outright failure, and we want to make sure that we have thought through those experiences from an infrastructure and resource perspective, but also from like a UI and a UX perspective. So as you can see here, we've got a scenario where we can run through increasing amounts of latency, starting at 100 milliseconds, increasing to 500 milliseconds, and then finally at 1,000 milliseconds. Each one of these steps of latency, it goes for about 30 seconds with a 5-second delay in between. And what we'd expect to see here is, at 100 milliseconds, probably not that much impact to the system. At 500 milliseconds, it will slow down. At 1,000, it'll probably break. Now, if you look at the top, while we're running this scenario, we have what's called a Gremlin status check that's going to run as well. And what this is doing is this is looking at the website itself to see how the website is responding to this latency. And this does a couple of things. Is one, it can monitor the behavior of the website so that we have sort of like a record of what's happening. The other thing is that it's a failsafe. So the status check will run before any attack kicks off to make sure that the website is returning a status code of 200. As long as the website is returning a status code of 200, the attack can continue to run. But if we get a different status code back, the safety check or the status check can actually halt the experiment entirely. So it acts as a safety mechanism. So one, it makes sure that there's not an incident happening already when we're running these experiments. And two, it can halt the attack and roll the system back to steady state if the system gets out of band. It'll also halt the attack if we get a timeout of 700 milliseconds. So Chris, if you want, you can go ahead and kick this thing off and we can see what happens.
Yeah, absolutely. So in this case, our status check, just to point out, we're actually using the product service itself as the status check. So if that service goes down, presumably our scenario should fail. You can do things, you can use something like PagerDuty and make sure you have no incidents that are open. Very flexible how these status checks are set up. I just wanted to point out how ours should work. All right, great. So let's kick off this scenario here. And we'll see it is indeed getting started. And so it's done our first status check. It looks like it's understood that right now everything is good, and it's moving forward with that first set of latency. So let's come back to our store. Let's refresh it a little bit. We can see the latency. It's not too perceptible, but it's clearly there. at 100 milliseconds, but maybe not something that's sort of earth-shattering or groundbreaking for your application. All right. I'm going to come in quickly while we're doing this test, and I want to point out something we haven't looked at in the Epsagon tool, and that is our ability to create dashboards. And so I've created a basic dashboard here, the first piece of which shows us that the duration of our calls to that product API. And so we should be able to see these spikes as they progress through the attack. I'll also point out, we have the ability not only to show technical measures, if you will, but we can leverage that payload information to create business level metrics. And so we have a chart here of revenue that's looking at our charge service. It's pulling out information, and it's telling us how much revenue we're generating. All right, we're on the second attack. Let's see. This one becomes much more noticeable. And so at this point, it's definitely going to be perceptible to a user. It looks like it just finished there. And so we at least want to put in something like a loading icon, right? So the user knows it's loading. It should be there any second now. All right, and it looks like it's tried to go on to the third step here, which is that 1,000 milliseconds. But at 1,000 milliseconds, we already know the product service breaks. And so this status check has recognized that, and it's killed the attack. And so we can validate that that status check has worked. At 1,000 milliseconds, our product service fails, and the whole attack should stop running. So everything looks great. It looks like it's working as we would expect here. All right, great. All right, go ahead.
One of the biggest questions that we get with customers is how do we safely do chaos experiments, and this is one of the best ways to illustrate that is whenever you're running a chaos experiment, you want to know that you have fail-safes in place so that you're not impacting your services and you're not impacting your teams, and the status checks are a very powerful way to ensure that. All right, go ahead, Chris. Sorry for interrupting you.
No problem. That's great info there. Okay, let's move on to our last set of attacks. We're going to do something a little bit different here. I think what would be interesting to understand, Austin, is within our services, where might there be dependencies that we're unaware of? And that is to say, is there a place in our application where one service failing cascades and impacts others? And I think we can probably do that using Gremlin.
Yeah, so there's a concept called a distributed monolith. You're breaking everything out into services, and they're supposed to be atomic and not, tightly coupled to one another. So if one service fails, it's not going to impact another service. But it's difficult to verify that without actually taking down the service and seeing what the impact is. So what we want to use Gremlin to do is take down a service that should not be a part of the critical path of this application. So the critical path is the ability to make a purchase. So touching the card service, touching the payment service in order to check out and buy something. So the service that we're going to target here is it's the ad service, right, Chris?
That's right. And so I'm not sure if we specifically called that out, but all that is right here is our little scrolling banner at the bottom. That tells you it's a great idea to trial Epsagon today. Let's remove that. Not that it's not great advice, but let's see what the impact would be having done that. And so I'm going to select just that ad service. We're going to come down to our gremlins. Let's choose Blackhole. It means we're going to drop all of the traffic. And let's see ultimately what that results in. Austin, what do you think?
I feel like we're probably going to break the ad service, but I think you built something pretty robust, so I don't think it's going to take anything else down.
All right. Well, only one way to find out. All right. Looks like we're still pending here. Let me come through, and it looks like now it's kicked off. And so just as we expected, the ad service has broken. It has disappeared. And what's really good is it hasn't impacted anything else, right? I can still add stuff to my cart. I would still have the ability to check out. That ad service, while gone, it's not ideal. It hasn't really had any downstream impacts. Now, of course, as someone on the business side, it's important to know when that ad service breaks, right? Because, in this case, it hasn't brought down the website. It might not be too visible. And so what we would probably want to do is set up an alert that tells us, hey, the ad service has errored out. It's probably something we want to look into. let's do that very quickly here in the Epsagon platform before we move on to our final attack. And so we're going to call this add service errors. We're going to do a trace-based alert. And we're going to say, let me come in and say, if we have greater than, let's say, 0 errors, obviously in production, you're going to have errors from time to time. So those thresholds, you'd want to calibrate appropriately. But in this case, let's say if we have more than 1 error over a 5-minute period, and we only want to do that for one specific route, in this case, our ads service. And let's do it even further. Let's say we only care if it's a 500. Right? And then we can set that alert up. And really beneficial here is the ability to send alerts in a very multi-threaded fashion. And so what I mean by that, maybe we want to send it to a Slack channel. Maybe we also want to raise something in PagerDuty and a ticket in ServiceNow. You can do all of that very quickly right here in the Epsagon tool. Let's just, what did I do there? We'll email this to both me and Austin. All right, so we've set up that alert, and now moving forward, if the ad service breaks, we're going to be aware of it very, very quickly here. All right, great. Let's go on to our last attack. I'm going to come down quick before we do, and we'll look at our service map for this application. We'll see here, in a production environment, you're probably going to want to alias these so that you know which service corresponds to which. It's not that important here for this demonstration because I know here is our traffic service, and I think we saw this earlier in that reference architecture. And we can see that traffic service ultimately speaks to and works with all of our other various services, whether that's a charge service or a product service or an ad service. And so I'm interested in seeing what happens if we do the same that we just did, but to the traffic service. What do you think, Austin?
I mean, I think it's going to break the site, but we want to see how things are going to fail, right? So yep. It's not just important to know that the site will fail, but knowing how it fails, again, so that we can prioritize our customer experience and ensure that that they always see the best that our company can offer. So what kind of attack are you building right here?
So I think we're going to do very similar to what we just saw on the ad service. So we're going to do a black hole. We're going to do it, in this case, as I mentioned, to that traffic piece. And then let's see what the chaotic results are here. All right, so give it a second to kick off here. Let's start refreshing, and ta-da, we broke it. So just as anticipated, that traffic service here is absolutely critical. And anything that goes wrong with that, anytime that service goes down, it's going to impact everything else on our site. One, we probably want to handle it better from a visual perspective. But two, we want to make sure that this never happens in production. That might mean figuring out what logic is in the traffic service and extracting it out and putting it in the individual services. Most likely that traffic service exists for a reason. And so what this really tells us is we better have a heck of a lot of redundancy to make sure that it never goes down.
Awesome.
Right. Yeah, great. I think that's all of the attacks we wanted to run today. Great.
Yeah, so let's wrap up. Let me wrap up with a couple of really quick slides for everybody. We'll show you to wrap up. Here's a quick slide that Chris can read off from a very happy Epsagon customer.
Yeah, absolutely. So we work with a lot of customers who are working their way into the cloud, have very heavy cloud-native workflows, Generali being one of them. And essentially, Epsagon gives developers at Generali Global Assistance the ability to connect the dots across microservices and to figure out what the customer is doing, where the customer has a problem, and how rapidly they can fix it.
Cool. And here's a quote from Lenny Sharp, who is the director of IT resiliency and engineering enablement at the retailer Target. They've used chaos engineering and Gremlin to break down their knowledge on monopolies and validate incident management runbooks, which has dramatically improved their incident response time in production environments. One of the first places that we start with our customers is helping them build out their reliability roadmaps, the reliability programs, and their incident management and SRE programs. Chaos engineering is a very useful tool for folks who want to figure out, look, we know we need more reliability, and we want to know where to start. And that's where Gremlin comes in. Our engineers will work with your teams to build out programs to help you be successful, to train your engineers so they start thinking about reliability proactively, start writing more reliable code, and they're leveraging Gremlin's expertise and then our tool with every code deploy that they have. So that's where we start. All right, so we're gonna start transitioning over to Q&A time. I see some folks answering questions over in the chat, so please get your questions in. If you want to follow up more with either one of us, there's a special offer and a free trial for Epsagon at epsagon.com/webinar. And then with Gremlin, you can do a more in-depth live demo and reach out to our team to get a one-on-one demo at gremlin.com/weekly live demo. And there you can also get a free Gremlin t-shirt, which are very popular at, if you used to see us at conferences, there's still an opportunity to get one of those at gremlin.com/weekly live demo. All right, so I'll take that first question that I see in the chat over there. I'd encourage everybody else that if you have Q&A to start dropping stuff into the chat. But Malesh, yeah, so I'd want to know more about your environment if you want to know about public cloud versus private cloud. I would just want to know, more about what your security requirements are. The way that we usually approach that is we have a full security team that works with your organizations to make sure that that your security team is happy. And we've got a lot of customers in in finance and even some military contractors and stuff. So from a security perspective, we have that buttoned up. We're SOC 2 compliant, and we've met their standards. So I'm sure that we can meet yours as well.
Great. Just a note for if you're asking questions, some of them, if you could sort of say if it's an Epsagon or Gremlin question, or maybe it's both, just so Austin and I can properly address it. All right, let's see. So Austin, do you want me to take a question?
Malesh, is that a question for Gremlin or for Epsagon from the on-prem thing? You can answer from your side, Chris.
So I think it depends what you mean by on-prem. If you're talking about the ability to trace something like a Kubernetes cluster that you host on-premise, you can certainly do that with Epsagon. If you're talking about the Epsagon platform and tool in totality, we are very much a SaaS offering, and so you wouldn't be able to install that on-prem.
And that's the same with Gremlin. Gremlin has a free product that is also a SaaS offering that we'll need to talk to our control plane.
All right, so I'm moving over to the Q&A part. I just see a couple of questions in there. I think there's one for Gremlin at the top from Nicholas. You want to take?
Yeah. Outside on-prem, work with lots of customers with not access to infrastructure. That's a great question, Nicholas. No, so the Gremlin tool needs to have access to the infrastructure in order to create failure. We work at the Linux kernel level, and so if you go to gremlin.com/docs, you can see how the installation works and learn more about that. And then if you go to gremlin.com/security, there's a link to our security practices, which talk about how we do the failure that we do. And that gives you a sense of how things work, and also the ways that we have limited our tools. So you know that, okay, this is how they inject failure, and this is also how they do it safely in a way that your engineers are still fully in control of. All right, so there's a question from Spencer. How is the system's platform dependency? How about its supportability on application language dependency? So Gremlin is Gremlin you can install just about anywhere, Linux, Windows, across all the public clouds. We're compatible with containers and Kubernetes. So I'd want to know more about what your architecture is like, Spencer. But you can drop that down in the chat as well. but I think we can probably make it work.
Yep, and then sorry, just in the event that that's also directed at the Epsagon side, if I understand correctly, so we very much instrument services. We instrument at the service level, and so the support we have right now, whether that's containers or serverless, Kubernetes, we're covering all the major languages. So if you're writing in Java or .NET or Python or Go or Node, you'll be able to instrument using Epsagon.
Awesome. So most of the scenarios of chaos tests involve performance testing as a prerequisite. How do I configure throughput? Right now we use separate tools for performance testing, one for chaos testing. Yeah, so that's a great question. They're not the same thing. When you're with performance teams, we see a lot of performance teams adopting Gremlin because it gives them another toolkit to precisely understand how their system responds to failure. Like when you're looking at, when you're doing load testing, that will tell you stuff about your system that that nothing else can. But on the other side, you want to see if you want to see how specific, latency or failures in the network at specific parts of your system impact other areas of your system. Gremlin is the best way to do that. And there isn't an all-in-one tool to do that. So usually what we do is we work with a performance team to do both of those simultaneously. Able to be integrated with GitLab's CI/CD pipeline, absolutely, 100%. Chris, is Epsagon as well?
So this is the GitLab question?
Correct.
Yeah, I'm actually not 100% sure, to be honest, which is not a great answer. I mean, we definitely have clients who integrate us in their CI/CD process because, in a lot of cases, instrumenting a service in Epsagon can be done just using things like environment variables, as an example. And so we certainly have users who integrate us into that process. Whether or not we have a core integration with GitLab CI/CD specifically, I'd have to double check on that. Sorry, Rajiv.
I assume that you guys have a really great API, and so you can integrate it into most CI/CD platforms.
Yeah.
Scenarios and attacks can be pulled stored as code and pulled directly into your source control. Absolutely, Daniel, and that's what we recommend. The way that you get the most success with your reliability efforts is by integrating Gremlin's API into your tool chain, so your developers just have access to it, and then you can sort of mandate and say, these are a set of reliability tests that we want to run with every code deployed based on our environment variables, based on the technology that we have. That's a really great way to make it scalable and repeatable. Let's see, Malesh, what is the resource overhead integrating that tool? I'm not totally clear what that means.
If it's for, and I'm not sure where this question is necessarily directed at, but if it's on the Epsagon side, we focus very heavily on overhead, and so for something like a service call, you're adding, maybe a couple of milliseconds. I think 2 to 4 milliseconds on average is sort of the additional overhead that instrumenting with Epsagon would require. So very, very minimal, almost sort of imperceptible.
Got it. Yep. Yeah, the same thing with Gremlin. I don't have the details on the agent, but again, it's exceptionally minimal. So it's so your system is still very scalable. Rajiv, if microservice configure auto scaling, then attack will happen in all instances. Yeah, so that's one of the things that you need to figure out. So you can test specific services, and I think it kind of depends on how your resources work from a container perspective, or if you're attacking services inside a container or inside a host. And that's actually one of the things that you want to figure out when you're running these chaos experiments is how the resources and the auto scaling rules actually behave. And so the fact that you're asking this question means that there's probably some resource constraints that should be figured out inside your system, which is exactly where a chaos experiment with Gremlin makes sense, so that you don't have to wonder how your system shares resources. OpenShift, yes, Gremlin supports OpenShift.
Also a yes from the Epsagon side.
Yep.
Can Epsagon be installed on-prem? I think we touched on that. Can one configure alerts be sent as SMS? Right now, I don't think so. But the honest truth is that we're adding new integrations all the time. If you had a use case where you said, I'd love to use the Epsagon tool, this is the only gap that we have, I'm sure we could set that up in a very short amount of time. We integrate with Telegram, I know, maybe as a substitute there for you.
Awesome. Conrad, there's tons of tutorials walking through the usage of Gremlin. If you go to gremlin.com/resources and type in Minecraft, there is a tutorial to inject failure into Minecraft. So you can actually play around with that. And then that page is indexed to the whole site, and you can look through some of the tutorials that we have, but there's a bunch of them on site. And then you want to take that question about the local environment, Chris?
Yeah, so it's going to be a yes for both. When I was setting up this e-commerce store, just as our example here, I started locally using Minikube, and so that support will definitely work in both cases for Gremlin and Epsagon.
These are great questions, guys. Anything else? Going once, going twice. All right. Hey, thanks everybody so much for coming. We had fun doing this. Chris, I hope we can do something like this again. But
definitely.
There's about 3 minutes till the top of the hour, so we'll give y'all a break in between your next meeting or whatever else you have going on. Stay safe, stay healthy, and thank you from everybody at Gremlin and Epsagon.
Thanks all. Have a great day.